What's poppin', dogs? Mr. Allen here solving some exponential equations in this video, and we're going to be using a strategy called U-Substitution, something that you're going to see a lot more going forward in mathematics from this point on. I'm going to start with this one over here, the e to the 2x plus 8e to the x minus 20 equals 0. It's got three terms here, and it kind of looks, it might not look like it for you right now, but kind of looks like a quadratic equation where you've got three separate things here equal to 0, and I would like factor to solve this thing. But I don't know how I'm going to factor this right now. But here comes the U-Substitution in a moment. I've got this e to the x, and over here I have this almost e to the x sort of thing. Let's manipulate this one right now. I'm going to go backwards with my power to a power rule of exponents and rewrite this as e to the x squared, right? Power to a power means I just multiply these two exponents, which is what I have here. I can go either direction with that to whatever I need to do, okay, right? I can choose how I want to manipulate that one, whether I want to multiply it in or take it out, whatever, floats my boat at that time or suits the problem that I'm doing. So then I have this e, or 8e to the x minus 20 equals 0. And notice that I have this e to the x here and e to the x here. Well, what I'm going to say is let u equal e to the x. And you might be like, why am I using u? Somebody chose a long time ago. It's a variable that we don't use very often. I think that's probably why we use u. Some people use, I don't know, other variables as well. I don't know what other ones people use. I think there was another one I saw recently. Anyways, maybe people are trying to be unique. But a lot of us use u, so I'm going to use that, okay? If I replace e to the x with u, I'd have u squared plus 8u minus 20 equals 0. Now that, as mentioned before, looks very much like a quadratic that I've factored and solved in the past, right? Usually we just see x squared plus 8x minus 20 equals 0. But the process is still the same. Does anything multiply to negative 20 while adding to positive 8? Well, my factors of 20 are 1 and 20, 4 and 5, 2 and 10. 2 and 10. So I'd have u plus 10, u minus 2, multiplies to negative 20, adds to positive 8, and I get u equals negative 10 for this one, u equals positive 2 for that one. Am I done? No. That's what u equals. Bring back the e to the x now. I would have, and I'm going to do that in blue so we kind of like connect these two things. We're going to have e to the x equals negative 10, and e to the x equals positive 2. Now, question for you. Is there any x value that would ever, any exponent, that would ever give me a negative output from a positive base? Remember, e is 2.7 stuff forever and ever and ever. No, there's nothing that's going to do that. So there's no way to solve this one, but e to the x equals 2, there is a way to do that. And I'm going to use natural logs on both sides. I will get these two undo each other. This is log base e of e. That x would come out front. A whole bunch of fun algebra. I'd have x equals natural log of 2. So this right here is absolutely acceptable on a free response or multiple choice. If they say they want like an exact answer, if you need to get a decimal, you can plug that into your calculator. And I would have, let's see here, natural log of 2 is x equals approximately, because we're using decimals now, which is a rounded number, 0.69314, so we'll do 0.693, okay? Boom, 0.6931, yep, boom. All right, there we go. A lot of times we'll use 3 decimal places in more advanced math, especially AP Calculus. This isn't AP Calculus, this would be more like pre-calc, but in AP Calculus they'll do 3 decimal places, either rounded or truncated. I'm going to leave this bad boy out right now in the event that I might need it again on this one. We'll see. All right. So let's go with this one here. Kind of same idea. Feel free to pause the video, try it, skip to the end if you want, or just let it play while you're working on the problem there. That way I get the watch hours. You want me to get the watch hours, man. I'm trying to make a living here, baby. I don't know. All right. Well, I know now looking at this that I'm going to go the route of like solving a quadratic. So I'm probably going to need to set this thing equal to 0, and I'm probably going to have to manipulate this guy right here as we did on the other one. So let's do that all in the same step. I'm going to have e to the e to the x squared, and then I have minus 6e to the x, add the 5 over, I get plus 5 equals 0. Then I will let u equal e to the x. And you'll usually see it written that way. Let u equal e to the x. And we write that down so remember what it is. E could, or u could be anything. You'll use it in trig. You'll use it in logs, all sorts of different stuff, where you're going to have u basically just becomes this more simplified thing so you can math with it and then plug the crazy stuff back in, okay? So now I have u squared minus 6u plus 5 equals 0. Does anything multiply to positive 5 and add to 0? Sorry. Multiply to positive 5 and add to negative 6. Yes, negative 5 and negative 1. So u minus 5, u minus 1. So I'll get u equals 5 and u equals positive 1 from these. But remember, we're not solving for u. We are solving for x. So bring back the e to the x for my u's. E to the x equals 5 and e to the x equals 1. And these actually are both going to work. So if I take the natural log on both sides or rewrite it, however you want to think about it, I'm going to have x equals natural log of 5. We'll get a decimal approximation here in a sec. This one, you might see the answer right now. You might not. Anything to the 0 power is 1. Remember that property of exponents. But if not, it's okay. But that one's going to be x equals the natural log of 1. So x equals 0. Yes, boom, there we go. All right. This one here is a solid like non-calc test problem where you need to know that e to the x equals 1 or anything to the x equaling 1, x is going to be 0. No matter what that base is, whether it's e, whether it's 2, 7, 11, 12, 142, whatever it is to the x equals 1, my answer is 0 there. So a lot of times in these problems, if it's a non-calculator test, they'll have this all set up to where this one gives you something that's no solution, like it's u equals negative 5 instead of positive 5. And we can't do that. You don't need the calculator to solve it. But this one ends up equaling 1, and you need to know that x equals 0. Okay? So keep that one in mind. That is very prevalent, I've seen on pre-calc and algebra 2, like advanced type log type stuff, and exponents, those kind of tests. Okay? But in any event, let's do natural log of 5 so we can get an approximation. It is 1.6094, so 1.609 is my approximate answer there. Bippity boppity, done. Okay. Thank you guys for watching. I appreciate it. Make sure you hit that like, subscribe, all that good stuff. If you have any questions, pop in the comments or ask for another video or find me in the halls if you go to school where I teach. But otherwise, have a great day, guys. Thanks for mathing.